Hi and welcome to my playhouse. And today, this is a PCB. I made this, so therefore this video is sponsored by JLCPCB, who is a PCB manufacturer in China, and it makes it really easy to design your own circuit boards and have them produced. At least the circuit board, well, you can actually more or less get all of it made to your design, and just they will ship it to you. So yeah, we're gonna design our own PCB. But first you're gonna get a little bit of backstory. So about 4 years ago, when I started to make videos here on YouTube, I was doing a lot of videos on batteries. I really like this idea of having my own battery bank with solar panels and battery banks, and for that I needed a lot of old car batteries. Most of these I got from my mechanic. He sold new batteries and he got the old batteries in, and Morten could come and pick up the old batteries, and most of them were okay-ish, but they could be better. So I was looking into restoring old batteries and desulfators, which is it's kind of a little electronic device that it pulls a little bit of power from the battery and it sends it back as a shock. This should remove some crystallizing inside of the battery. I am not into that kind of physics, but more or less it's a little electronic device that takes some power from the battery and it puts it back into the battery very rapidly and breaks up the crystals so that the battery should be able to restore some of its youth. Let's call it that. And I did some videos on that. I actually bought a desulfator, turned out to not be very good, and in some of those videos I showed some desulfators that my cousins had made. Both of my cousins are engineers and they like this too, so they built these. I forget who built which one, but it's not important. They're made on breadboard and like really crappy soldering and stuff, but they worked really well compared to the one that I bought. These were great, and I did a video where I showed that on an oscilloscope, and ever since people have been asking me where to get that desulfator, and well, the business Morten thought, maybe I can make this and sell it to those people who want this desulfator. Like, this is one of the desulfators. Here 4 years later, I thought, let's give that a try. You don't have to be a rocket scientist to make your own PCB, but you do need to know a little bit about electronics. So today we're gonna be designing our own PCB. I have already the schematics here, and we're gonna have a look at how we do that. And keep in mind that this video is sponsored by JLCPCB, so we're going to be using their tools, which is not bad. It has become a lot easier since I designed my last PCB. So making a desulfator is not complicated. This is the diagram for it, which I have printed out from the program that we're going to be using. Go check that out. Okay, the resource that we are going to be using for making this PCB is this EasyEDA. It's something that is related to JLCPCB. If we go down into the bottom here, we can kind of see that there is some services here, and that lists 3 things that this company is doing. They have parts, manufacture PCBs, and they maintain this program, it seems. This is the page that you're greeted with if you go to EasyEDA.com, and you need to create an account. It's free, and I am already logged in. I have this nice little empty expression up here. So we are gonna go and we're gonna open the online edition. You can also download it to your computer and work with it from your computer, on your computer. I'm just going to do it on mine. Everybody loves this cloud computing, right? So online edition, and it opens up this editor, which is, I must say, it's rather neat. And I've been doing some projects It took me about a day to figure this out. Saw some video tutorials and so it's not that bad. So first we need to create a project. I have my playhouse over here, and I have a couple of projects that I've been working on. This one was the first project that I did. I thought that I should just start by making the PCB and putting in components, and that turned out to be the wrong way to do it. So I gave up on that and I started over, and then I started by making this a diagram. This one, which is the same that I showed you on the paper here, which is just the one that I printed out. So this is the thing that we're going to be making. I have already made that, but yeah, I'm gonna try and show you how to do this. So instead of using this one, we're gonna create it again. Awesome, right? So we're gonna go up here and we're gonna make a new project. So new project, and we're gonna call the owner, that's me, and new project, we'll call it just for the filming purpose. So we have the option of making this a private or a public. Anyone can see the project, but only you can modify it. It's great for community building stuff, I'm sure. We're gonna create this project. So save, and we should get a new folder over here. We need to build a circuit board, schematic it's called. So we're gonna make a new schematic. It has already made a new schematic over here, so we might just be able to start this one. We can start by giving it a name. By double clicking here, I'll call it the same thing. There, and yeah, we could keep modifying this. This would be awesome. We need to make this schematic, and there's a lot of stuff here that we need to find. So picking the right components means that we need to not only find the right component, but also find the I've made this with the stick-through components because I'm gonna make this as a kit, and I could easily have made this as SMD, surface mounted devices, but if I want people to solder this together themselves, well, put through components or stick through, I don't know what they're called. Well, they're easier to solder, so I'm gonna be keeping to that. It's old-fashioned, but more people will be able to do this. To get components, there is a library over here, and we can get different stuff from here, or we can also just right-click out here and pick component. So we get a library here, and I've already searched for the 555 chip here, and we can scroll down and we will be able to find that timer circuit somewhere down here. Down here we get some, there's a programmable timer, there's a dual timer, there's a single timer, that one. Unfortunately, this is a surface mounted timer, so we don't need that. Let's call it LM. There. And we get this timer in different packages. And we can just click and we can see the packages. There. That's the thing we want. So here we can get it from LCSC, the component company, and they would also be able to supply us with some prices on this. It seems that it costs 27 cents per timer. We can also go over here to user contribution. Well, other users that has made this timer and made it available in the system. So if we go over here, we can see there's 179 LM555, and if we wanted to look in a specific way, we can see that there is a lot of packages available here. People that has made different looks for this, different drawings for it. I'm gonna find one that looks exactly like it does on my drawing so that I don't have to think. Okay, it took a bit of time, but I found the timer that I have been using in my previous drawing. It might have been stupid of me to pick this timer because there is, for example, 2 pins up here that are swapped around compared to every other timer that anyone has ever made. But well, I used that one, so To make it easier to find it next time, I believe that under here there is an add favorite, so we can kind of save it somewhere. I have no idea where it went, but yeah, maybe next time it will be easier to find it. So we'll pick that one. Place. We'll just put it somewhere. We can pick one more, but we can just right click and it disappears. And so now I'm gonna pick something more easy. We're gonna go and get a capacitor, and we're gonna just gonna write the capacity of it. So 47 microfarad. Enter, and we should get a lot of capacitors. And then we just go through the capacitors and find one that looks about right, like this one. It has the capacitors symbol here, and it looks kind of a capacitor on the drawing as well. So I believe this one will do just fine, so we're gonna place that. It's just a tiny little symbol, and that goes out here. And we need a couple of resistors, so we're gonna right click, pick component, and that's just one. Search, and we should get some resistors. Let's check that one. That kind of looks like a resistor. Looks okay. Yeah, let's place that one. We kind of have 4 resistors. They're not all 470 kilo, but the sizes are the same. So I'm gonna be placing some more resistors, kind of in the right spot where I'm gonna be needing them. Now we need another capacitor. This is a tiny little nanofarad one, so this is 1 nano, so 1 N. Let's search for that. So I just go through them. Oh, this is actually not bad. That looks about right, so we're gonna place that. We have a number of those. Let's see, 1, 2, 3, 4 of those. So we're placing that over here, there, and over here, there. That's those capacitors. Then we need a transistor. I've been doing some work to find out what components I was going to be using here. And some of the components I found, oh, they're very expensive. So I found some other components that was way cheaper than the first one that I thought that I was going to be needing. So this is it's a power MOSFET. Okay, let's find the right one. That looks about right, and that's the right package. So we are placing that one. Actually have to turn that around. That's kind of important, so we need to mirror that. So we will flip it vertically. There. Yes, very important. This tiny little diode in here needs to be right. Then we need a couple of diodes. We have a power diode. R420. Let's search for that. There. Let's check that out. Looks about right. Place goes here. Then we need a couple of coils. This one is very close to what I want. As you can see, these are some big coils, and yeah, they go through the circuit board. So this might just do it. I'm gonna try. I have another coil, and that's 1000 microhenry. I might have more luck there. So finding out what everything is called and which packages that you need is a big part of this. And this is the inductor that I finally. It took way longer the first time. Now I do have somewhere to look for it. So they're gonna be placed somewhere around here. We need another capacitor, but it's gonna be similar to that one. So I think we're gonna borrow this one and copy that and put it over here. Paste. Then I have a fuse up here. It's a special fuse. It's one of those tiny little mechanical fuses that reset themselves. It overheats and it breaks, and then when it cools down, it reactivates. We can find that. These are it. They are called poly switches. Self-resetting fuses. Okay, found that one. I stole it from my previous project, so we're gonna place that. I think I'm only missing a connector. There, we added some voltage and some ground. Now we have all the components for our little circuit board here. Now we need to wire them together. Let's get rid of this one. But I've actually done quite a bit of work already, so now I will go and I will save my work up here. I just managed to throw away my project, so I could start over. I cheated and I took a copy of my old project, and now I've just all the components here. Some of the, well, all of the components have the right names and the right sizes, capacity of them, and they're in the right spots. So when you have created, right now I have done this, but if I hadn't saved this, what you do is you go up here and you just save. I was saving as, and yeah, that didn't work out for me. We are gonna be connecting all of these electronic components together, and I just wanted to show that you can switch and turn them around. We already did that with the MOSFET over here, but if we take this capacitor here, switch that around, and it actually has to go that way, but keep it going however we want it. There, and it's back where it was. So now we need to put all this electronic together with some wires, and that's the tool up here, wiring tool. So here's a wire, and we kind of pick that, and it goes up, and we're gonna be connecting that over to this fuse over here, there, and that one goes on to this point there. I'm just gonna do this rather quickly because otherwise we'll never get this done. So you can kind of see how this. You get out of the wiring tool by just right-clicking there, and there's connection. You can kind of see when I hit the end of a component, I get a black dot, and when I come down here to a connecting wire, I get a red. That is very hard to see, but it makes a red dot, which means that that is connected. So we have two of six here. Around here. There, I believe that I'm done. Let's see if I missed anything. It looks good. It really doesn't take long when everything is lined up like this. I stole it from the other drawing, and I just removed all the wires, and now I put them back in so you can see what I did. There's other tools available over here, but I think I'm good to go here. So let's remember to hit save again. There, don't wanna do that over for no reason whatsoever. So now I can go and create the PCB that I want, and I have my diagram. Oh, I am actually missing something. I have a couple of wires up here, those two. There we are. Anything else? I think we are about there. Good, let's save again. Save. Now we want to create our PCB. We have how everything is going to be put together. So up here we can convert this to PCB, and when we press that, it opens up a new PCB for us. It has decided how big this PCB has to be. Well, this is way too big. We can put it down on something smaller. I'll put it down on this one, and that was kind of small. We can change our PCB. We can make a really weird one. They are gonna be really pissed at the factory if we do that. They might actually not care. So we're just gonna make a new one. To make this PCB a bit smaller, this is how big it is right now. If we select it and go up here to set PCB outline, we can see that this is 6.7 centimeters times 4.5 centimeters. So let's make this 50 millimeters and this 40 millimeters and apply. And we got a smaller PCB. Let's throw our components up here. You can see we have the components here, and they're all like wired together. So when I move a component like this IC here, well, all the connections, they move with them. So I'm gonna move that up here. First, I need some holes in here. Well, we can still go over here and we can pick component, and we can just search for hole. Okay, mounting hole was a good word to search for, and over here under user contribution there was a lot of holes. We're gonna place a hole in each of the corners so that this board can be mounted. You can kind of zoom in and zoom out. I haven't totally figured out how to do that, but it depends on where you put the mouse, where it zooms in and zooms out, and it's not that accurate always. I don't need this text for the holes. There, I can fiddle around with getting them perfectly nice out into wherever I want them, but I could also move my IC a little bit here and move it according to where I put it last time, and I can take this text and put that inside. Then I have my fuse. I can see that I've put that down here next to this hole. I have this diode, and I have put that over here. You can kind of see where the diode is, what it's gonna be connected to, and yeah, we need to turn this around so that it turns the other way, and we can just do that up here and just turn it twice. That means that now it's connected to the fuse, and that line goes up here. It's a kind of a big job to get everything into the circuit board and be logical, and that takes a lot of fiddling around. This diode goes around about here. I'm just redoing this. I don't want to do it all over. This connector needs to be turned around that way and goes about there. And we have this inductor. There. We have another inductor. That needs to turn around that way. And it goes about here. And we have this capacitor here. There. There. And yeah, then we have all the smaller things. I'm gonna do this really quick. PCB so far. You can mingle around with this forever and ever, I assure you. But now we can start tracing out our PCB and figuring out how to connect everything to one another. This inductor up here, that looks really stupid. I think that needs to be turned around a couple of times. I've made that circuit so much simpler. The idea is that you don't want these lines to be crossing too much. If you can prevent that, your circuit board is going to be way easier to make. We have different layers here that we can work on. We can turn on and off different layers. That wasn't anything there. There is top silk layer. That is something that is printed on the PCB, so you can see where everything goes. We can have that and we cannot have that. We do have some of this text that is also upside down, and it's really easy just to turn that around there and have that. And you can mingle that around, have the text look perfect. And you want to put some wires here. So let's start with we have the top layer and we have the bottom layer, and that's where we can put our traces. The copper that is going to be connecting our components. We have both top and bottom layer. So if you can't do something on the top layer, well, you can always fix it on the bottom layer. Okay, let's do the bottom layer. That's the normal thing. You connect stuff on the bottom layer. So I'm gonna go edit. I'm moving the pencil down to the bottom layer, and we're gonna be connecting some stuff here. Select the trace tool, and we can select different sizes of our trace. And the size of our trace is right here. That's how big the line between. We could just check that. If I say this capacitor here needs to be connected to this inductor over here, so we can make a trace, and that looks like this. That means that we will have a piece of copper between these two. This is the powerful side. We don't need small traces here. The bigger the better. So we can make this trace a lot bigger. Let's make it 0.5. That's probably not big enough. 0.5. When we then do a trace, we'll see that our copper line just became bigger. We can do it even bigger than that. Let's make it 2. We have a good, nice big trace here. Like that. A lot of these high capacity things, well, you want to make those with big traces. So you can manipulate this and get it the way that you want it. Then like that. Now we have a trace there. And then just go here like this. And every time I press right click, I see where everything has to be connected to. And that makes it really easy to start connecting stuff. Like this one, you need to connect that to there. Maybe we want it to go a little bit that way and then down there. Doesn't matter. This one needs to go. Where does that? It needs to go around here, so we need to bring that up this way. There. It makes it really simple, right? This is some of the high power stuff. As soon as we get into the smaller stuff, well, it can become more difficult. So, like this little resistor down here, we don't need that big a trace for that. Okay, we need a big trace from this one to that one. There. Oh, down to that resistor. That probably also is pretty much overkill. We have all the potential high power stuff done here. So yeah, we can pick a smaller trace now. So we can go down 0.3 maybe and do the smaller stuff. I'm sure there is a total science of how to do this. And we can see we need to go down there. That's gonna be interesting to get down there. So you can't cross these lines because then you will short circuit something. So you have to be a bit creative. Let's trace some of the easy stuff. So now I have laid out most of the board. I have a couple of difficult ones. This one needs to go from here to there, but there is something in between. This one needs to cross 2 lines over here. That's gonna be a drag as well. Sure, I can bring it up this way. I don't that way here. It's not pretty, but it would work. Now this one is more of a problem. How do I get that over there? I would have to bring that through the same hole and over there. So, and that one is I have to go far and above to get out of there. So what I will do, I'll change and fix that on the top layer. If we go to the top layer, you can see that we have that one and we have that one, and now it's very easy to just pick that one and make that go on the top layer instead. And I don't have to worry about the blue lines because that's on the bottom line. So you can connect that one and this one. And so our PCB is done. You can mingle with this forever and ever to get it just perfect, to have the text lined up and look awesome and stuff like that. But right now everything is connected and it should work. There are some really neat tools here. Let's just, for the fun of it, go and saving our PCB here. So now we have a sheet and we have a filming PCB. We can kind of see what this is gonna look like. You can get a photo view here. That's what it's gonna look like from the top side. You can see the bottom side. That's where all of my connections are. The top side, very few connections. There was that one, and there's this one. That's where the silk layer is, so that I can see what different stuff is. I can write right now the capacity of all the stuff is wrong. It looks really nice. It should also be possible to make a 3D view. Don't know if that's gonna work today. It does. So I can see what the PCB is gonna look like on the top and on the bottom. Awesome, right? We have made that, and I can of course go and do other stuff. Now we'll go and see the PCB that I did, because it did a little bit more, but we actually pretty close to what I did. So this is the filming project. Let's go down to the desulfating project here. Well, let's close that. I have saved it, so it's okay to close it, and we can also close the schematics. We can go down here and see my schematics that I did for the real project. Over here is the PCB that I made, and it looks like this. It looks very similar. That's because I have been copying it. I've fixed all the values of the component here. Also, I have on this PCB, I've made sure that all the connections that I could do, I've done both on the top and the bottom layer. Top layer together with the bottom layer, we can see that a lot of the connections are redundant. So I've connected it both on the top and the bottom layer. If something breaks on the top layer, well, it might still work on the bottom layer. I've put some text on there. Here, I've made My PlayHouse Desulfator Kit stuff. Now I would want to have my PCB made. I have a PCB and it's ready for production. So I have already had these PCB made, and oh, they look like this. That's the PCB. Came in from JLCPCB, and they look awesome. I have though found some of my little design flaws, some small issues that I want to fix before I order some new ones. For example, god damn, this is Inductor, and it goes in here, and the leads, well, it's very wobbly. Those leads are not very big, and the holes are huge for it. You can kind of see those wobbling around in there. So if it's possible for me to make that ever so slightly smaller, that would be great. That goes in. Oh, that's actually, this is the big one. This is 1000, but it's the same issue. The holes are the same size, so yeah, just as wobbly. Also, this diode It's not as bad, but it's also very big. It's big enough. So, yeah. I have kind of purchased enough so that I can build 100 of these. So when I have this figured out and everything is good, I'm gonna be selling them. These first editions I'm gonna be selling to my patrons. I'm gonna be making a version 2 because I have made too many 22 kilobyte resistors here. I have made an error somewhere when I did the first board, so there is only that 470 kilo and all the other ones have the wrong writing on them. So yeah, only have a few of these, so they're probably already gone when you see this video, but yeah, patrons will be getting that. So these leads out of the inductors, 0.45 millimeters. So I guess a hole of 0.5 or maybe 0.6 will be sufficient. The diode is about 1 millimeter, a little bit more than 1 millimeter. So let's see if we can fix this for my version. Let's try this up here. We have the hole here and it seems like that the hole is like 1.5 millimeters. So for the inductor, the hole doesn't need to be more than 0.7. Let's see what happens. Oh, it got wider but smaller, so we need to put that one down there as well. So we have a smaller hole but a bigger soldering thing. That's great. Here. There, that one. Good, that one. So those holes are smaller than the diode. We are at, oh, that's 1.7, and we need that to be 1.2. There. Then there is also this tiny little diode down here. Those holes are also way too big, so we're gonna put in 0.7 down here as well. There. I think that was about it for this time. So of course we need to update our kit here. That one. Now we are at a 1.1. The 1.1 kit. Okay, so I've made my changes and I want to order this PCB now. To do that, we go up here and press this generate fabrication file. Jabber, whatever. When we press that, it comes out and say, do you want to check if everything is as it's supposed to be? It can go do that. I do actually want to put these layers on before we do that, so that will actually be stored as well, and let it check if it's okay. And it says that it's apparently okay. Already here we can see what prices we can expect here. If it's the first time you do this, you get a really good discount. You can kind of get an idea. I don't think 10 is going to be that expensive, but we're going to generate this Jabber file. We could go directly and order it, but we're just going to generate the file. It's going to download it to my computer there, and then we're just going to go over here and we're going to start making our order over here. I'm going to log in. I think I have an account. Seems like My PlayHouse has an account. Okay, I can see that last time I ordered PCBs, they were 1.6 millimeters thick, but they work really well. But let's just go home and then go down and order now. So over here we can add our Jabber file. Right. I've moved it and I placed it in the temp directory. My PlayHouse Kit 1.1. Open that. Didn't like the long name it had, so I had to do something, and now it loads as it should. We have two layers, 40 times 50 millimeters, and there is the equivalent in inches. Successful. It's gonna look like that. 1.1. Awesome. For watching. Internal joke there. Smaller holes here. Good. It's gonna be very exciting to see if that works. Size. Yes, I get a price over here. I can get 5 of them for $2, really cheap. Then there is some shipping down here, that's more expensive. The cheapest way to get them is that way. We're gonna get that. A quantity, oh, we can order a lot, 80,000. Well, I only have 52,000 subscribers, so I think we're gonna go for less. Let's see if we order 10 of them. That might not be unreasonable. That's $5 for 10. Shipping there. PCB thickness 1.6. We want it in blue. We can pick here. There's different options that you can pick, and you have to check the price every time. Surface finish, that just became expensive, so let's try and go back. And then that disappeared, so we don't want that. Then there is how much copper we need there. We can get a gold finish. Yeah, I don't think anyone want to pay for that. More details. All the rest is probably okay, but 10 PCBs is just, I need a little bit more than that. So, but you can see it would cost me $5 for 10 PCBs. It will cost me $5.8 ish for the shipping here to Denmark. It's gonna weigh 70 grams, but let's get some more. Let's get 50. That's an engineering fee suddenly. And then the boards is $4.8. Total price is about $12. So I get 50 boards for about $21, $22. Let's try that. Add to cart. There. And we can check out securely. Let's see what happens. It has picked different shipping over here, so now it's suddenly very expensive. So we can go back to this e-pack here, which was the cheap one. There. Do we have any coupon codes? Oh, a couple of coupon codes. They are really interested in selling here. I don't have a promotion code. I really should. They have offered that I would get free PCBs. I will pay with PayPal, and I will use one of my coupon codes. There. Oh, we got a discount. Maybe I could use 2. I'm not going to. I'm gonna save the next one for next time. Continue, and I will have to pay for this. So I placed my order. This is the first order I did. I ordered 10 pieces. Now I've ordered 50 pieces. $12.80. That's so cheap. It comes out to $16.83. Last time it was a total of $5. Shipping, I didn't pay for any shipping last time. If they really want to sell this, you can also get $8 off if you want to go purchase your component at JLCPCB.com, which I haven't tried that yet. I can expect that I get some PCBs in a week or 2, I guess. That's how easy it is to make a PCB. I have of course gone and I bought all the components that needs to go onto my PCBs as well. The PCB itself is really, that's a big part of the work to get that up and running. I'm gonna be doing another video where we put together one of these and we test it out. I have an oscilloscope in the basement that we are gonna be using to see it working on a battery. So yeah, I'm gonna be selling these along the way. When you see this, I would expect that they have sold out over on Patreon. These version 1.0 with the wrong resistors on there. I'm sure somebody's gonna want those. Probably when you see this, there will be 50 more available. So be waiting for the video where I'm gonna be telling you how to get hold of those with all the components. I'm gonna be making a kit, as it says on the back. Oh, don't autofocus on me. It's a kit. You get the PCB, you get the components. You have to do the soldering work there yourself, but I'll show that in the video where I solder everything together. Probably gonna do that on the version 1.0 board here because, well, I have it, so I can do the video now. So thank you very much for JLCPCB for sponsoring this video. If you have a PCB project of your own, well, I'm sure you can figure this out as well. Thank you very much for watching my videos. Do subscribe to my channel so that you can see me again, and have a really nice day. Bye bye.